PET, which stands for polyethylene terephthalate, is a clear, strong, and lightweight plastic belonging to the polyester family. It is typically called polyester when used for fiber or fabrics, and PET or PET resin when used for bottles, jars, containers, and packaging applications. PET is the world packaging choice for many foods and beverages because of its hygienic, strong, lightweight, shatterproof, and retains freshness. It is most commonly used to package carbonated soft drinks and water. Consumers can identify PET containers by the triangular #1 resin identification code found on the bottom of PET bottles and jars. Let's take a look into how PET is made. The basic building blocks of PET are ethylene glycol and terephthalic acid, which are combined to form pellets of PET. These resin pellets are then heated to a molten liquid that can be easily extruded or molded into items of practically any shape. More specifically, when the two raw materials of PET are combined under high temperatures and low vacuum pressure, long chains of polymer are formed. As the mixture becomes thicker, the chains grow longer. Once the appropriate chain length is achieved, the reaction is stopped. The resulting spaghetti-like strands of PET are then extruded quickly, cooled, and cut into small pellets. Now, let's take a look into how PET bottles are manufactured. After cutting the resin into small pellets, the pellets are sent to the bottling manufacturer. The bottle plant mixes PET resin pellets into regrind recycled plastics that has been reduced to flakes. Plastic loses some of its physical properties when repeatedly heated, so manufacturers must limit the amount of regrind they use, typically capping this ingredient at 10% of the total mix. Unless producing clear bottles, dyes are introduced to the mix as well. When building a preform, an extruder melts the PET and regrinds mixed at temperatures of about 500 degrees Fahrenheit. A screw inside the extruder compresses the PET mix and injects the nearly molten material into molds. The mold produces a bottle preform, which is sometimes called a preresin. The preform looks like a thick-walled test tube, often including the bottle's characteristic screw top. The preform cools as it travels to a machine called a blow molder, and may need to be brought back up to the manufacturer's specific temperature for that operation. If necessary, the bottle manufacturer raises the temperature of the preform in a small oven. For stretching the preform enters a two-part mold that closes around it. The inside of this mold is shaped exactly like the finished bottle. Inside, a long needle pushes up through the preform, which is suspended with the screw end facing downward. The needle stretches the preform upward towards the top of the mold, which will be the bottom of the bottle, and simultaneously blasts enough pressure air into the preform to force it against the sides of the mold. This stretches the blow molding process must happen quickly in order to maintain the bottle's integrity and consistent shape. Some manufacturers weld a separate bottom piece to the bottle during the blow molding, while others produces a bottom from the preform along with the rest of the bottle. For cooling and trimming, the bottle must be cooled almost instantly or it will lose its shape when gravity causes it to creep downward in its malleable heated state. Some manufacturers cool the bottle by circulating cold water or liquid nitrogen through the mold. Others elect to fill it with a shot of air at room temperature. The mold typically yields a clean bottle, but some flash may occur at the bottle seams where the two molds have met. If so, operators will trim away the excess material and add it to the regrind. Outside of the bottle manufacturing process, commercially available PET grades include unreinforced to glass reinforced frames, retardants, and high flow material for various engineering applications that typically require high strength and/or higher heat resistance. Additions of fillers like glass fiber help improve the impact strength, surface finishing, reduce warpage, and several other benefits. Some of the other key advantages of PET is that it's known for its good gases like oxygen, carbon dioxide, and moisture barrier properties. It exhibits excellent electrical insulating properties, and it is recyclable and transparent to microwave radiation. As I mentioned before, PET products are 100% recyclable and is the most recyclable plastic worldwide. PET offers significant advantages like weight, durability, versatility compared to alternative materials, making it a widely used polymer in the packaging and textile sector. As they have a short lifespan, almost all PET products marketed are transformed into waste, making PET a priority target for recycling. Low diffusion coefficient makes PET much more suitable than other plastic materials for use as a recovery recycled material. Now let's take a look into the recycling process for PET. Post-consumer PET bottles are collected and processed through a series of special washing processes or by a chemical treatment to break down the PET into its raw material or intermediates, which are further used to produce recycled PET flakes. The growth of bottles recycles has been facilitated by developing of processing technologies that increase products' purities and reduce operational costs. The most adopted method for PET recycling are chemical recycling by hydrolysis and mechanical blending chemicals recycling involving the production of terephthalic acids and ethylene glycol to utilize them for making other synthetic chemicals. However, cost effectiveness and environmental friendliness makes mechanical recycling the most common for PET recovering methods. Overall, recycling and reprocessing causes a decrease in melt viscosity and average molecular weight, which can negatively affect the final product's mechanical properties in terms of tensile and impact strength. The use of recycled PET as a matrix for composite materials based on glass fiber reinforced virgin PET could be a cost-effective and environmentally friendly way to upgrade the bottle-grade recycling PET into an engineering-grade PET for injection molding. I found that very interesting. This concludes my video on PET, and here are the sources that I used to make this video. Thank you for watching. You guys have a good day.